gosh. Wait, no, that's not my intro. Hello. Hello. So today we are going to be doing, well, today, I say today as in, I guess it is technically today. So, right, today we are going to be doing assignment 11. So we're just off the back of doing assignment 10. 10 was pretty alright. 10 had some counterexamples which were a bit annoying, but we managed to persevere, mostly because the counterexamples were in fact really easy to find. It was just that I started trying to prove them, which I shouldn't have done. I should have, determined the validity of the statement before trying to prove it. So whatever, it's water under the bridge. Let's go do assignment number 11. So assignment 1. Function t defined for some integers where t, the base case, is 1. What? T, the base case? No, T1, the base case is 1. And it just goes up and up. That means it's 1 plus k, which is also 1, which is n plus 1, so free. T equals free is free plus some k, which is what, 2? It's 2. And then plus 1 again, so it's 9, it's 6. And then so for 4, it's starting to reach a pattern, which you can see. It's probably gonna be 6 plus, wait, what? 6 plus 2, yeah, 6 plus 2 plus 1. So, yeah, that's our pattern. Great. So now you want us to find the smallest value of n such that t of n is larger than 100. That's quite interesting. So you could do, I guess. Okay. Okay, so let's say some k is in fact larger than 100. So let's try and do this without just brute forcing it, because brute force is never any fun. So that means it's t of k plus k plus 1. Now we know the t of k is in turn k minus 1 tk minus 1 So these two disable each other and it becomes this. And then if you go one level deeper, it's this. So these two cancel out. It's 3k. And so on and so forth until it reaches 1. So what does that show to us? How can we utilize this? I don't know. No idea. Because we don't know how big k is. Great, so we're back to the start. The thing is, this is recursive, and what right now we're trying to turn it into something iterative, which is always quite hard, isn't it? Well, sometimes quite hard, depends, but in this particular case, it seems to be non-obvious. Again, you could just guess. It's no fun. Okay, wait, I think I have it. So, this is quite succinctly described by some kind of quadratic sequence, which is something that I thought of from the start, but I didn't say it, which I really should have. So this is 2, this is 3, obviously, this is 4. And so the increase from one of these is just 1. So, given that information, we can say that ABC equals 1, C stays constant, B, however, increases by 1, A increases by 4, then to 9. So yeah, now we can model it like this. Hmm. Okay, good enough. So now we need to figure out values that are valid. So now we can do it like 3a plus b equals 6. No, sorry, not 6, 5, and 4. No, 9 to be not 8a. So what we're doing is we're taking 1, 2, and we're taking 3, and this is 2 minus 1. This is 3 minus 1. Now we've got that. That's a simple simultaneous equation that we can solve, and doing essentially the same thing again. We now have this equals to negative 1. Is that right? Sort of, I hope. So if a equals negative 1, b equals this number. E. I see what I did wrong. This is literally just written wrong. Okay, oops. Because I was thinking, there's no way that those values are correct. They look wonky. Wonky answers are never right. They never give you a wonky answer. They love their nice, clean answers. That's political commentary, by the way. Not political. Societal commentary. I don't know. So now we got a. So now it's looking like this. Just in turn, looking like this. So now that's B. Now we got some C, which is just 1. Great. So now let's test this out. Let's plug in the values. 16. I guess 4. Why not? Plus some 1. And this should equal 10. And it does not. Wondrous. It explodes to some far off infinity. Not desirable. Not desirable at all. We're sure this is even right for any of the other numbers. No, it's not even right for any of the other numbers. Why are we worrying about? Oh, because this is a negative. Oops. Okay, so now that's wrong, but in the other way. Yay! Oh, because if this is wrong, then C is 0. Yay! Okay, no, this is right. So our t of n any n is simply equals to half of n squared and half of n. This must be larger than 200. No, 100. So you put it over here. Get a little bit of this. Then how do you multiply to get these two? I have no idea. Mm, What's factors again? I don't think this can make two. No, it can't. No, obviously not. It has to be larger. My bad. I guess we can do a quadratic equation. Kind of equals to this. And obviously, that's a plus. So for the power of shitty fucking estimations, it's 14. Wow, this is so mathematically unprecise. There's literally no chance that this could be wrong. Fuck. I guess we could just, compute it. It's not that hard. So 14 times 14 is 196. That's 44 already. So that is 105. Yep, so that's good. That is above 100. What about 13? So that's this plus this divided by 2, which is evidently not above 200. No, not above 100. So yeah, that's our value. Wait, that took way too long, by the way. This is not that hard a question. That took way too long. It helps that I'm slightly dazed from having done the previous assignment like 10 minutes ago. So, okay. So, locking in, F is 0 to 2 is defined like that. Sketch a graph. Yes, I will. Turning point is at 2. When it's 2, it actually equals to 0, so it's actually here. Like this. Okay, so this equals this. As you get minus 2 it, then that's just that. Lovely. Same applies here. That's 1. 4. That's a 0, and that's a 0. Wondrous. Now they've asked us to continue sketching the damn graph. Because it's periodic, it just looks like this. This is -1. This is a straight line. This is not a straight line. This is a straight line. This is not a straight line. Oh, this is a straight line. This is not straight. Oh, come on. Not a straight line. Okay. So yeah, that's 2. That's 4. That's 6. Wonderful. Line. I, using the substitution, y equals that. Find a real value that satisfies this. Dubuchi. Oh wow, my pen just slipped right on my hand. Oh hey, it's not actually that much stuff to do. Good. I like it when there's not much stuff to do. I like it when it's quick and easy. It's not valid. Therefore, x must be equal to 8. 8 is x is free. Move on to do I. Find the beautiful value of x to satisfy the equation. Hmm. Oshiroi. I feel like squaring it is going to cause us to lose a value. But there is only one value of x, so if it does happen, then too bad. Hmm, 2x. Is this 12? And the only question remains how on earth you get rid of that nonsense. Hmm, might not be possible. Nope, no idea. Value of x that satisfies the equation is lost to me. There are various ways that I can think of to manipulate this, each uglier than the other. Oh fuck, this is actually the way to do it. I don't know why I keep overcomplicating things. This isn't that hard, but It just felt ugly to me. I don't know. It just didn't feel like something that you do in the TMUA. I don't know. Well, let's verify. Nope. Completely fucking wrong. Okay. Well, I'd say fine, but it's kind of expected. So yeah, on second thought, easy solution, nowhere to be found. Oh god, I am yawning. Oh, my days. Oh wow, I found where I made my mistake. Ta-da! Okay, wow. So that makes this irrelevant. Okay, yeah, so it's 10. Because negative 3 would just break it. Right, great. Use the substitution to find the real root. I really envy like the lucky guys who got to do this for their step instead of like the absolute horrors that you've got now that require all of your high school knowledge in order to even attempt, and even then you're coming away with like a coming away with horrible scores. I'm not doing step, by the way. Not doing step because step is miserable. I'm doing the lovely, lovely, dovey TMUA, which I mentioned before. Much easier. Mm-mm. Okay, well, hmm. When in doubt. Ooh. Hmm. So it is this. Because the other one's negative. Okay, well, horse over, I guess. Watch is that wrong. What surprised me? That's the entire step question? Is finding some fucking roots? Jesus. Okay. This is kind of like USUB, isn't it? At least the technique is not dissimilar. Since z equals to this, you got this, which you can solve trivially, I hope. Where does the negative go? Here. Now you got z is 10 to 12, or z minus 12. So z is therefore going to be 2. That's going to be that. It's this. All of the real roots. X2. Sound right? Next up, you got some B. Might be a good idea to factorize that mess first, though that isn't possible. Instead, you could just cry. You could just cry about it. That sounds fun. So you shove everything over and then cube it. That creates a terrible, terrible, terrible quintic. Or quartic. I'm not sure which one it is. I think it's quartic. Which is not lovely. Does not inspire joy. So there's obviously fuck all way you're factoring either of those, so can't factor them. Fuck it, I don't know. We ball. Looks like this. Is it a substitution again? Could be. Let's say y is the stuff in the bracket. Wait. Okay, so if you complete the square, you get this, which is nice and lovely. How do you get rid of the negative 11? Maybe let's continue pursuing the y route. So now you got y plus 11 divided by 2. B, B, B. Boop, boop, beep, boop, boop, boop. Boop, boop, boop. Boop, 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 boop. Boop, 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 boop. Boop, 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 boop. Fuck it, we bought. Okay, so this is a square root of y. This is an ungodly mess. This is a similar looking ungodly mess. This is 9. The thing that really makes it special is this. Ah, get rid of this. And then since this is negative, these two cancel out. Lovely. Lovely, lovely. And then from there, it's just mop up. Say that knowing that there's still plenty of work to be done. Now's another substitution. So therefore, this is equals to 3. Oops, sorry. This is y, his is 9. Now I've got y equals 9. It's x. Ah, but there are multiple. Whew. Thank Lord I got that. I hope. Oh, it'd be a pain to verify, wouldn't it? Yeah, I'm not doing all that, but good for you. Good for you. Yeah, I think that's it. So now, warm down. Given this, and that they're both integers, find the values of m and n. I'm going to ignore the instructions that are telling you to do substitutions because that's stupid. I don't want to do them. M equals 3, n equals 1. Shocking! We did it. Right, so, trivial questions aside, let's go do the other one. I agree, this is a little trickier. Not by much, but, it's the thought that counts or something. I don't actually know what it's the thought that count means. Um, no, I do. Why did I say that? It's the thought that counts means something, an action that is ultimately inconsequential, but its intention bears goodwill. Yeah, fucking hell. Let's see. And we're close to the end. This was an alright assignment. I like the questions. I feel like they were at least somewhat. They were really easy, but I like really easy. I don't know. The first question was tougher than the SEP question. The warm up question was goofy, but also I don't know. It was just a technique I hadn't used in a long while, so it took me a bit of time to remember, but then I cracked it. Also, I feel like I got less sleepy as I continued. I don't know. I during the break I didn't really do much. I went outside. I kicked the ball for a bit, and then I don't know. I got some water. I drank like half a pitcher of water. Maybe the water was like slowing down my brain for the first half. That might be it. I mean, it was a lot of water, so makes sense that I was digesting whatever. Anyways, let's continue. So now we've got this. I guess we could sub out. So now we could get Wait, did I do it wrong? Oh, I did it wrong. Only I can do something wrong this frequently. Right. So now each of these are individually equal to zero, or could be equal to zero. So there's one. I guess I can log it just to prove it, right? Okay. If we log both sides, it becomes, I guess, natural log, but whatever. There's no difference. This becomes x here. Is that how log laws work? I'm pretty sure that's how log laws work. Skipping some steps because I'm a lazy bastard. Got this equals one. And you can, I'm not doing all that again. Strata conclusions negative one by yourself. Left as an exercise to the viewer. So, yeah, that's this. Surprisingly quick. I will actually take a read at this. That might be useful. No, that's the wrong. That page doesn't exist. Great, wonderful. The one time I actually want to read something, it doesn't exist. Fuck's sake. Right. Let's go check our answers. Wonderful, 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 wonderful. Yeah, it's a triangle number. So yeah, it is 14. Let's grab our tiki out. Tiki, 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 tiki. Graph is continuous. So it is. X equals 3. X equals 10. Ooh, ugly. I think we got that wrong. Wait. Yeah, we definitely got that wrong. X equals 2. Oh, good. Glad I spotted that. Right, got that right. Okay, so we'll have to go back there. This is correct. This is also correct. I'm not checking any of that. Nonsense. Ah. Right. So, I might have to go eat after this, actually. Yeah, that might be good. I've been eating early today. I'm a good boy. Yes, I'm a good boy. So, what do we do here? This is one of the easy ones, right? So, we did a sub, multiplied both. Found you. Okay, well, that makes all of this irrelevant then. Great. I love wasting my time. So, oh, nope, that's also wrong. because you really can't make 6 with 2 and 1. So the way to approach this is stupid fucking quadratic formula. 16 plus 8. Fourteen. Pick up the hot sauce. That's equals to y. Which is also equals to negative. Oh, it's equal to square root. You kidding me? Ah, you're killing me here. Okay, only the positive one matters, so it's this, which is equals to this, plus this. Lovely so far. Negative. Cancel out into this. That's not that bad. Is that correct? Would be bad if it was not that bad, but I got the wrong answer. Fuck. Oh yeah, okay, that's right. Yeah, done. Okay, well, that's that. Oh, I used wrong. I used wrong color. I need to use Tiki, and Tiki has confirmed us for one more step assignment completed. So now that makes, I believe, 11, or at least 11 once I finish doing 8 and 9, which I conveniently forgot to do. But that's not relevant. I did like most of them, so I'll count it as most of them. So yeah, I'll go and have do I have lunch now? I mean, it's not good to eat so late, is it? Could have no, it's not lunch, it's dinner, isn't it? Could have dinner now, could not have dinner now. Oh, you know what I could do? I could do step 9 and step 8 on stream, then I could go have lunch. Because I don't think I'm ready for sorry, dinner. I keep saying the wrong thing. I don't think I'm ready for dinner just yet. So yeah, I guess we'll do that. Uh I've never heard of a streamer ever referring to like in real life things. Maybe like Tommy in it once. He had to go do like an essay for university. Well, technically, what I'm doing is also something for university. It's just I haven't gotten in yet. I'm trying to get in, and that's why I'm doing all this. Oh, sorry. Cambridge interview was watching. I mean, I'm enraptured by the elegance and beauty of mathematics, and that's why I'm furiously doing step assignments so that I can experience this so lovely, the exotic sensations of the fucking square root and shit and substitutions. Right. So going to half done. I don't want to do half done. Let's go do 9 first, so I get that quick dopamine boost. Oh, I should close this. How do I do that? Okay, so this. Right, so for I actually am a little hungry now. I just said I'm not hungry and now I'm hungry. So let's finish this quick. For I is so defined as the isosceles triangle A AB equals BC. The line BA and BC are extended by equal lengths to to D and E. We want to show that there are two angles that are the same. You can only use congruence to establish with SAS and the facts that angles in the triangle are supplementary. They sum to 180. So we've already done I, which is showing that the two angles BCD and BAE are equal by showing that two triangles are congruent. So the proof is as follows. BCD, oh wow, that's quick. So BCD, so this bit here, oh, I can't use Tiki, is congruent with BED, which is, huh? Fuck? Oh, I meant B. Sorry, I meant BAED. Bad? I ain't bad. That's not triangle. That's a fucking straight line. No, it's not straight line. It's like, oh, that is a straight line. What was I writing here? Did I just ruin my own proof? Okay, give me a sec. BAD and BAE. No, that's correct. So BD and BE are equal to each other. B is the same angle, and BA and BC are also the same. Since they're congruent, that means it's the correct answer. DCA and DAE. So this bit, this bit. Okay. I remember why this question was so miserable now, but I'm sure with our new expanded mathematical tools of substitution, we can solve this. As long as I substitute my own brain. So, okay. The angles in a triangle are supplementary is useful, but not relevant ultimately. In order to do the proof, we are going to have to utilize congruency. And so the only congruence that matters is CAE and CAD. If we can prove this congruence, we will prove that those angles are in fact related to each other. And nothing else matters. Let's take a look at what else, what other delusional ramblings I've written here. CAD is equals to ACE. Isn't that exactly what we're trying to prove? Am I dumb? Oh, no, it's not. Okay. You know what it's not? How did you prove that in the first place? Wait, what? Magic does not count as one of the ways you can prove things. FAC? Fuck. Where's the F? Honestly. Or is that an E? God damn, his handwriting is awful. The person who wrote this must be an idiot. How on earth are they equal to 180? What are these delusional ramblings? Okay. I think these can be safely ignored. Okay, so also I think this can okay, you know what? Let's just take all of this and shift over. I don't care. This was clearly not written in a sane this is clearly not written in a sane. Come on. Clearly not related, written by sane mind. There you go. Piss off. Right. So congruency of CAE and JC congruent is as follows, right? CA is the same. You can only use SAS. Oh my god, wait, we have two ready. Yeah, we fucking do. Yes, we fucking do. CE equals AD. And now we just need an angle. Oh, would you guessed it? Now we just need CAD equals ACE. So that was what that was about. Can we use can we use a supplementary fact to prove this? I'm sweltering for some reason. I don't know why. We open the door. Right. Okay. After I'm solving this, I'm going to lunch. I'm hungry. Dinner. I'm hungry, but. Oh, I know why. I know why I say lunch and not dinner. It's because I never use the word dinner. Because at home, I don't speak English. I speak another language, which I choose not to reveal for now. But when I'm with my friends, I always say lunch because, we're at school, you're eating lunch. Oh, that makes sense. Anyways, back to the proof. So, angles. So, thinking about it, the straight line reasoning is lovely, but doesn't actually matter. So, I think the straight line bit's just irrelevant. But, hmm. It's definitely got something to do with the angles in the triangle. Like, I'm telling you, it's got something to do with that. I'm telling you. Hey, I'm telling you. Wait, we know these two are equal to each other. Oh, I sense a proof incoming. I sense a proof. I sense a proof. Vertically opposite angles. Does that matter? Does it? I have no idea. Um, so we can prove with sum of angle equal 180, D equals E, and ver up angle that CAD equals ace, which is true. So we've proved that. No, wait, no, we fucking have it. No. No, that's not C. That's not C. It's an angle. That's F. We're labeling this F. So F, AD FAD, FCE. So now the gold bits are approved. Okay, so this is progress. Oh wait, we already proved that previously. Fuck. Okay, well, never mind then. Okay, we've made no progress and we're just sitting here. Okay. Zero progress. Rage bait successful. Zero progress achieved. Hmm. Listen, I didn't know I can crack I3 if I can crack I2. So I don't know. Like, okay, wait. Question mark implies C A E equals EC. Wait, we've been looking at the angle so far. What if we try looking at the side? Is there any way to prove that those two lines are equal to each other? Okay, so let's say we assume that we ignore this. Let's say we assume that DC equals AE and that D equals E, or sorry, ADC equals ACE, AEC, which again we already proved previously. So yeah, this congruency works, and so therefore I is true, which is kind of a buttfuck like pull out my ass thing, but whatever. So now we're looking at triple I. Deduce these angles are not equal. No, deduce that these angles are equal. Which is fairly obvious. I mean, just BCD. Wait, BCD. BCD. Yeah, BCD. Wait. BCD. Oh no, BCD. Oh yeah, okay. No, I brain farted for a moment there. Okay, BCD minus ACD is equals to AE minus EAC. Therefore, back and BCA equal. Okay, good enough. Jump. Right. Let's go look at the answers. Oh, we're not looking at the answers for any of the other ones. We're just looking at Euclid and his stupid fucking angles and his stupid fucking groups. Oh. Right. So DC equals A. That is the assumption they make. Sake, bro. fucking dickhead of a Euclid, he's a fucking dickhead, right? So he assumes that, and I guess I mean it is fairly obvious, but I didn't know that at the time. Never take anything for granted. So yeah, I'm gonna go have lunch. I'm gonna return at some later point. Not now, obviously. I'm gonna end the stream. Yeah. So I'll be back and then we'll finish off 8, 9, 12, maybe 13 if we have time. But I've also got a bunch of papers to mark and then I've also got autographs. So yeah. Without further